The broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great event on tap, but before we get started, we do have a few questions or a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, please know you'll be able to access it on demand later on. We will be sending out an email after today's webinar that includes a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question. We'll take as many questions as we can after today's presentation before the end of the webinar. And also, to close out today's webinar, we will be doing a drawing for 3 $50 Amazon gift cards. So stick around. Hopefully your name will be one of the lucky 3 chosen. Okay, with that, we'll go ahead and kick off today's webinar, which is Understanding the New Enterprise Multi-Cloud Backbone for DevOps Engineers. Our speaker today is Mark Cunningham, who is Senior Solutions Architect at Aviatrix. Hi, Mark. How you doing? Thanks for joining us.
Good morning. Thanks for having me.
You're welcome. Well, I'm going to put myself on mute, just let you get right to it.
All right, well, thank you very much. All right, so thanks everybody for joining us today. It really is a privilege to have so many of you from the DevOps community show up who's interested in learning about what we're doing in the cloud. As you may have heard, my name is Mark Cunningham. I'm a Senior Solutions Architect at Aviatrix. Been working in IT for about 21 years with a background in networking, and I spent the past decade working in the InfoSec space with a focus on web and mobile application security. More recently, I've moved my focus into sales engineering and cloud. And also I do have a bit of an interest in Python, and I run PyCharm. So in this webinar, we're going to cover giving developers secure profile-based access to the cloud, the basics of connectivity with the public clouds that we refer to as transit, and how you can set up the security function of egress filtering from within your VPCs to meet compliance and remediate other threats. Now, all of this I'm going to be presenting to you within an infrastructure as code model using Terraform. So by the end of the webinar, you'll be able to pull down all the examples that I'm going to show you. You can start building these things yourself. So we'll jump right in. Now, what you'll see here is a fully developed high-performance architecture that highlights our advanced feature sets like the firewall network and high-performance encryption, but we're going to stick to just a few of these. What we're going to cover is what does it look like when an organization starts down this path and organically matures using a few of these architectural design patterns. I'm also going to cover these concepts using a storyline narrative that closely resembles the journey that several of our customers have taken when they started using the Aviatrix platform. So meet Michael, everybody. Michael is the hero of our story. He's a developer at sometravelcompany.com, and he has an idea for an app, and he pitches it to his boss, and it revolves around pitching last-minute cancellations of airline tickets and hotel rooms, as well as ones that haven't sold yet, to the customer about to make a purchase. So he gets permission from his team leader, gets signed up from the manager, gets a budget, and gets a small provisional access to read from the company data lake. Designs a quick query, scoops up a few chunks of data, and he goes to work on his app. Now, his company is very independent-minded, so it's up to him to manage his own cloud and manage his own access. So after a quick Google search, he finds a vendor called Aviatrix and gets to work. Now, for those of you, the 0.004% of you who are new to Terraform and don't have an installation or don't have the Aviatrix provider set up yet, this will be a quick step-by-step. You'll install Terraform. I hope you're familiar with Brew. You'll install Go, and then you'll need to export the Go path environment variable to a folder in your home directory or wherever you installed Go. Then you'll clone our provider repo and then CD into that new directory. You run your format, you run your build, and then the last thing you'll need to do is to create a Terraform configuration file with an entry that points to the Aviatrix provider. If you don't have the Terraform configuration file, that's how you can make one, and just make sure it has an entry in it that looks like this. So you'll also need to have your controller launched to start building with these scripts that I'm going to use, and there's a couple of ways to do that. For those of you who really want to stay completely in code, there is a link to the start page of our Terraform provider, which has the README for setting up the controller. But we do encourage you to visit the UI at least once, and you can do that by launching it to the marketplace. Both the links are right there on the page. It is really highly recommended you take a tour of the UI at least once. I mean, all of your advanced networking, visualization, and troubleshooting tools are in there, so it's good to become familiar with that. So Michael is now ready to go, and he can start building his VPN endpoint and connect to his cloud, start writing his app. And he does this by writing a very lightweight Terraform script that breaks down into 4 parts. The first of which is an access call to the Aviatrix provider. He references the controller's IP and his credentials. Next, he's going to write his first resource call that instantiates an Aviatrix provider object of type Aviatrix_gateway, and he's going to name it AVX-VPN-GW. Now, he fills in the values using the required information, such as all the relevant details that are going to come from your VPC. The gateway name and the instance size are up to you, but the rest of the values you'll pull straight from your AWS panel. And the last entry is the CIDR range that will be used by the DHCP service to IP the connecting host. And this is all you need to actually deploy the gateway in itself. The last 2 chunks are made up of creating a VPN user, and you'll need to port over the actual gateway name that you used in the last script. You'll give a username that you pull over from the last script, and then you also type in an email. Now, lastly, you're going to configure a profile. And now what Michael did here is not necessarily what you will do in practice, but I wanted to give you an idea of how these things play out. So he started with a base rule of allow all. He popped in his username, and he has a couple of deny scripts in there. You really wouldn't kind of wall yourself out of your own network, but I want to give an example of how these things work. So taking a closer look at the VPN profile, you'll start with a base rule, you'll pop in your username, and then you have the exception blocks, which start with an action, which will obviously be an opposite of your base rule, mapped to a port and protocol and a target CIDR range. And that is all the code you really need to get your VPN up and running. But keep in mind, there's a lot more features that can really make this thing work well for you. You can set up connectivity to other VPCs in other clouds. You can enable built-in features like the network load balancing to distribute your user traffic. And that functions as active-active endpoints for where you drop in your cloud. And you can also use a SAML integration to pull in a variety of identity providers such that you don't need to maintain a separate list of users within the controller. So Google, Okta, Active Directory via LDAP, Active Directory via Azure, all the major IDP players we have an integration for. And you can also throw in multi-factor authentication with Duo as well. So at the end of the day, you end up with a complete solution for accessing the cloud such that you don't require any other tools to get up and running. So, well, as it turns out, Michael's last-minute deals widget was a big hit, with over 15% of the site's traffic using it in some form or other to drive their purchase. So his boss formally upgraded it to application status within the line of business. And as well, other teams took notice of Michael's notoriety, and they came up with their own ideas to integrate with his. He was granted dedicated access to the company data lake so that now he can run his analytics routines in real-time streams as opposed to point-in-time queries that have to be manually uploaded. So the following day, the other team showed up at his door eager to get started. But the way that he would approach it, he remembered a meeting he had last week that the cloud governance team had been clamoring for all development projects to be contained within the same account. So Michael is going to have to build that access for all the other teams. So after doing a little more research on the doc site, he decided to build an architecture that makes use of the Transit VPC. Now, the Transit VPC will act as a hub for VPC connectivity. You can use this to spoke off to other VPCs, and you can interconnect other regions and other clouds, as well as connecting to on-prem customer environments, any data center you'd like. Now, you can get other VPCs connected with AWS peering, like you can do here with this code. This is using the native AWS provider. This is outside the context of the Aviatrix provider. But if any of them were to need encryption, or if they were to need to access the data lake themselves, then connecting to the Transit VPC as a spoke, or what we call an Aviatrix encrypted peering, it'll give them the encryption they need and help them overcome the transitive routing limitation native to AWS. So now that he's got his other VPCs talking, he can now connect to on-prem. And the Aviatrix transit network comes with the added benefit of being able to plug right into the VGW. And that's where Michael creates his static connection to the company data center. Now, all that is left to do is to create a VPN user profile for the other team members to use when they connect to the cloud. And remember, you can assign the same policy to multiple users. So here in this example, if you don't mind having Captain America and Doctor Strange in the same CIDR range, you can go ahead and put them all on the same list. Now, as with any killer app, explosive growth is right around the corner. So no sooner did Michael get his initial transit architecture built, did demand around his application begin to skyrocket. More developers were reaching out to him for design ideas, integration requests, and the like. Security and compliance team came around asking for more segmentation, access to logs, servers they can pen test. The list goes on. It really felt like the hockey stick just showed up and said hello. So Michael kind of set to work, and as he was helping the teams break up into separate VPCs for dev, staging, and prod, he realized that there might actually be a better way to scale his transit architecture. Now, he remembered that you now can use the AWS Transit Gateway, or TGW as we call it, to scale a cloud transit architecture in a very simplistic fashion. And with the TGW orchestrator, he would get to take advantage of security domains and connection policies to manage all of the routing for him. So essentially, the more he read about the TGW, the more excited he was to use it. So he spent a few minutes with Lucid Charts, opened up his Cloud9 and started chopping it out. What he came up with was a hybrid transit architecture that combined the Transit VPC. And did you notice that the Transit VPC changed to the edge? We're kind of switching the name around once we get to this architecture, so it's not confusing with the AWS Transit Gateway and Transit VPC. We want to make sure we're not stepping all over ourselves. So the two of them together are going to give him the robustness of the TGW, along with the versatility of the edge VPC. And like I said, that can spoke off into other encrypted peerings within his same cloud, or to the other ones like Azure and Google, should you need it. And maybe you need some kind of specialized way of connecting to a VPC, such that you need to DNAT or SNAT the traffic, or you have to map the address from one CIDR range to another. Some kind of complex connectivity use case, you can actually use the site to cloud function, and that would also stem from the edge VPC. So to take a closer look at the AWS Transit Gateway and how it deploys, using the Aviatrix platform, you can assign your VPCs to security domains. And VPCs that are in opposing security domains are either connected to or segmented away from each other based upon their connection policy. Now in this diagram, you'll see that Michael has 4 security domains. Feature 1, Feature 2, shared services in Aviatrix Edge. And in the chart at the bottom of the slide, you'll see that the 2 feature divisions and shared services all have routes to each other because they're in the connected list. But the Aviatrix Edge is in the not connected list. So feature 1, feature 2, feature 3, sorry, not feature 3, shared services all have routes to each other, and the Aviatrix Edge is isolated away from themselves. So the way that you can manage routing using the extensibility of security domains and connection policies allows you to fully manage the routing, such as point and click, drag and drop. Now, finally, we're going to talk about the egress security features built into the Aviatrix gateways. Now, everybody likes to access the internet, including VPCs. So why should the NAT gateways get to hog all the action? Nginx and Apache web servers all need to reach out, get security updates, update their package managers, and ultimately, deploy or serve their respective microservices. Now, Michael wants to give his servers secure access to the internet by using the Aviatrix gateways, and he can do so in a way that is governed by policies that function at the level of DNS. So using a whitelist or blacklist, which you can see on the right-hand side in our Aviatrix Terraform, he can create an egress rule set by selecting port, protocol, and DNS name. Now, after he applies it to a gateway, he's going to find himself in full control of all outbound traffic leaving the VPC. So this, in concert with needing to restrict any inbound traffic to his VPC, the stateful firewall function on the opposite side of the egress control is always at his disposal. And what does this control give you? It really gives you an ability to manifest PCI compliance in a really functional way. Now, Michael knows that while his application will probably never host his own cardholder data environment, he will more than likely be interacting with systems that could put his environment in scope and therefore be subject to PCI compliance. Now, what he has deployed here shows a gateway in each VPC managing all outbound access on a per VPC basis. You can also opt for a model where outbound traffic will converge on a single VPC routed through the TGW. This is called our centralized egress model. Now, regardless of which egress model you're using, both can deploy themselves across two gateways using two availability zones for an active-active HA model. And as soon as you deploy this, SNAT automatically kicks in, and the outbound traffic from the private subnets within the VPCs is going to be implemented with a zero route to the ENI of the egress gateway in the public subnet. So if you have this deployed in HA, the traffic is going to be load balanced across each of them, with the subnets of the VPC divided equally. Now, let's not forget about the user interface. We've got step-by-step instructions within each of the architecture use cases that we support in case you need a little bit more of a frame of reference. And once you start getting good at the UI and you learn your way around the workflows, keep in mind that even if you're just starting with Terraform, what you can do is you can pull individual Terraform builder scripts right out of the useful tools menu. And so if you're just starting to get used to and start with infrastructure as code, this is a great way for learning to manage your cloud with Terraform. So back here to the overall architecture. This is a good high-level map to keep in the back of your mind as you start to build out or extend your cloud architectures. We didn't get to all of the use cases that are present here, but we will next time. And we'll talk about more features in depth, like the firewall network, being able to deploy Palo Altos directly from the UI, or being able to enable high-performance encryption from on-prem, across clouds, across regions. We'll probably have to develop that into the next story as Michael makes it big and has to spin off his last-minute deals app into his own company. But anyway, that is the story and the webinar for today. We'll go ahead and take any questions that you might have.
All right, great. Yes, there's plenty of time for questions. So if you do have a question for Mark, please go ahead and use your GoToWebinar control panel and submit your questions. We'll go ahead and get started with the ones that we have, which is, let's see, first question. To what level do you support SAML with your user VPN service? And what client OS do you support? So, what client OS support do you have?
Sure. So we do support SAML integration with a variety of identity providers, say Google, for instance. You will need to use the Aviatrix VPN client to actually do that SAML integration. We have a workflow that will show you how to develop your SAML endpoints, how to configure your metadata such that they can be properly consumed. and processed by the gateway, and then with the actual connection created and terminated by the endpoint and our client. The client OS availability we pretty much have every single OS available except Fedora. So Windows, Mac, most Linux distros, Debian, but just all the ones we spoke about except Fedora.
Okay, great. Next question here. Does the Aviatrix Transit Orchestrator with AWS Transit Gateway support high availability and VPC segmentation? And how do each of these work?
Oh, so let's take that question apart. First, we have the high availability question with the Transit Gateway. So the AWS Transit Gateway is an abstracted networking service that doesn't, comport itself to any kind of component. Like, it's not an EC2 instance. It's not any kind of service that requires any kind of load balancing. It's already fully redundant. I imagine that there are, for every one TGW service port that serves a region, for every one goes down, there's probably 29 more ready to take its place. There's no need to provide any kind of high availability within the Aviatrix Transit Gateway. With VPC segmentation, we did cover a little bit of that on the slides, getting onto where we had the TGW attachments form. The way that segmentation works is based upon the security domain. Let's say I have 4 VPCs, 1, 2, 3, 4. I put one of them in a security domain, I put another one in another security domain, and then I put the following 2 in another. Unless I specifically connect those 2 with the connection policy, then those VPCs do not have routes to each other, and you end up with segmentation by default. So the VPC connectivity that you provide is going to be a very purpose-driven event, and it's very simple to use for point and click, drag and drop to get your segmentation and connectivity going.
All right, great. Just a reminder, plenty of time for questions. If you have one for Mark, please go ahead and use your GoToWebinar control panel and submit it. Our next question here. I'm not sure if the native AWS Transit Gateway supports Direct Connect yet. Can Aviatrix help with that?
Sure. So I do believe as of last week, or was it the week before, Direct Connect became available to connect directly to the AWS Transit Gateway. However, you're still working with the limitation of being able to process, 20 BGP routes from your on-prem or your customer environment up into the spokes. The way that our Transit VPC or Edge VPC works in this case is that we have the ability to have Direct Connect plug right into that VPC, either through BGW or through our site to cloud connectivity. There's a variety of ways. And using that, you can connect your Direct Connect and you can overcome all of the routing limitations with that.
All right, cool. Next question then. Our security teams, our security teams are looking at deploying our firewalls in the AWS for inline inspection. Any recommendations on this?
Yeah, absolutely. So we have a new product that is available within the multi-cloud backbone Aviatrix platform. It's called the Firewall Network. I did hint at this a little bit, but what this does is it allows you to overcome all the inherent limitations with the prescriptive guidance of dropping your firewalls directly into a VPC and running, let's say, running a pair in active passive. Or something similar where you drop your firewalls into a VPC to connect it to the TGW, and across these 2, vendor-driven prescriptive guidance methodologies, you have these, subjective requirements of BGP, routing, IPsec, tunneling, SNAT to get the traffic across. And then equal cost multiplexing if you want to aggregate connectivity across multiple instances. Well, what we've done is we've kind of really mopped the floor with making this kind of integration work, and we do that by putting our gateways in front of the firewalls that you'll deploy with. And doing that, we can remove all the limitations inherent with bringing your firewalls into the cloud. you no longer require BGP to manage routing. You no longer have to have encryption for the sake of connectivity. There's no IPsec tunnels. You can manage your originating addressing, so you no longer have to SNAT, and your workloads can keep track of where the traffic came from. And then there's no need to run equal cost multiplexing. We can actually run the bandwidth in a fully connected FireNet instance at the level of 6 gigabits throughput in and out of the firewalls.
Excellent.
So,
okay.
just to wrap that up, we really do have a firewall integration plan for inline inspection, north, south, east to west, ingress and egress story that's highly effective.
All right, great. We have one more question here. So if anybody has a question for Mark, please go ahead and submit it using the GoToWebinar control panel. We'll go ahead and ask this last question here, which is what other network use cases are supported with Aviatrix beyond what is discussed here?
I would say the one that we probably didn't touch on at all, which is definitely one of the more interesting ones, is our ability to enable high performance encryption. So traditionally, when you have an IPsec tunnel that you connect into your cloud from an on-premise environment, even if you have a direct connect that's running at a 10 gigabit pipe, you're still only going to be able to encrypt 1.25 gigabits of that. So what we've done is we have remodeled and revamped the way that an IPsec tunnel will actually make connections. And with that, we're able to achieve 10 gigabits of encrypted throughput using a direct connection from an edge VPC down to your data center or your customer on-prem environment. We also extend that high performance encryption across regions should you need to go from an edge VPC to another VPC in AWS. That can extend at 22 gigabits. You can reach across the regions at a 5 gigabit pipe. You can reach across clouds at a 5 gigabit pipe. There is essential mode for flicking a switch and making it so that you can make full use of the outbound capacities of your instances that are present in AWS.
All right, great. Okay, so that's all the questions that we have. I'll give the audience a minute or two to see if we get any more questions. And while we're waiting, I do want to remind the audience that today's event is being recorded. So if you miss any or all of the event, or you just want to listen to it again, you will be able to do that. We'll be sending out an email after today's webinar that includes a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website. So you can always go there. Just go to devops.com/webinars and look in the on-demand section, and it will be right there waiting for you. And also want to draw your attention to the slide that's up now. We've got some engineers who are waiting to chat with you. If you have any questions for Aviatrix, design assistance, technical questions, demos, whatever, solution architects are waiting for you to talk to them. So I think that's all we've got for today's questions. So I do want to thank everybody who did submit questions. Let's see, I told you about the on-demand, and I know that I still owe everybody a drawing for 3 $50 Amazon gift cards. So I'm going to go ahead and do that real quick, and then we'll close things out today. So our first winner for the $50 Amazon gift card is Christopher Carlton. Congratulations, Christopher. Our second winner is, let's see, Jeff Kaya. Congratulations, Jeff. And our third winner today is Rudy Wilkinson. Congratulations, Rudy. Okay, great. Well, that is, I guess that's all the questions, and that's everything that I have on. So Mark, I do want to thank you for such a great presentation, lots of good information. And I know that I actually do want to remind the audience that if you have a question for Mark or anybody over at Aviatrix, please feel free to get in touch with them directly. They have lots of good stuff going on over there. So please don't hesitate to reach out to them. Mark, thanks again for such a great presentation. Really appreciate it.
Thank you so much. Thanks for having me.
All right, great. Well, this is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.